Okay, so for now, I will just move on to Pearson test. Pearson test is kind of test that based on the method of covariance, and it is designed to measure the association between two continuous variables. Okay, so and then the hypothesis testing is implemented to test if they are having linear relationship. Okay, so and to run it after running this Pearson correlation test, right, we will have this output called R output. And most of the time the R output is always between -1 to 1. How do we interpret this result? So when the number is near to -1, we can say that they are having perfect negative association. And when number is 0, right, you can basically conclude they are having no relationship. And lastly, if number near to 1, you can say that they are having positive association. Okay, so in today's demonstration, I will just simply use the two columns of data from here. Okay, so the two columns that are highlighted here. Okay, so before I start my demonstration, I still want to teach you another intuitive way to help you visually tell if the two continuous variables they are having correlation. Okay, so it is called scatter plot. So and I believe previously my teammate has introduced before, so I'm not going to tell about more details. Okay, so to how, but I will just demonstrate to you how do we plot the scatter plot. Okay, so basically what we do is we just simply select our data sets and insert and use the recommended charts and find the charts we need. So basically the first one is the one we need. Okay, so for this graph, right, for this plot, the y-axis is the second column here, the x-axis is the first column here. Okay, so and basically, right, from this graph you can tell that these two variables are having a positive linear relationship, right? So okay, maybe after, okay, if I add a trend line, you will see, you will kind of have idea, right? So but however, this just give you an idea. We still run the test to tell if they are having a relationship. Okay, so now I just going to demonstrate you the Pearson test. Okay, so this is a formula. Okay, and okay, let's look at the Excel sheet, maybe it's better. So okay, so this is a formula. Okay, so basically first we need to calculate a Pearson value. So Excel has a built-in function to allow you to quickly calculate the Pearson value. What you can do is just type in the equal and Pearson and select the column 1, the first column. Okay, and then we select the second column. Okay, we just hit enter. Okay, so now we got the coefficient here. So this is the coefficient here is basically the R output that I talked just now. So the 0.93, you can tell that it's very near to 1. So that's why we observe here they are having a positive linear relationship. Okay, so okay, now let's continue because we still need to do a hypothesis testing to tell if they are seriously having the linear relationship. Okay, so the n basically is a number of observations that we have. So we just use a count function in Excel to just count any of the column. Okay, so we have here, so basically it tells that for these sets of data, for this column we only have 25 observations. Okay, and for the t stats here, let's just follow this formula. So it's kind of use a coefficient to times up the square. Okay, and this n divide minus 2. Okay, so over, okay, square root, so 1 minus this one and to the power 2. Okay, yeah, so this is our t-test that we have. So remember, we always need to calculate a t-test for our this Pearson hypothesis testing. Okay, And the degree of freedom is pretty simple. We just use an observation, number of observations minus 2. Okay, so for the hypothesis testing here, we need to use the built-in function again called t-distribution. Okay, so why we will use t-dist here is because the sample size that we have is kind of small here. Okay, so this t-dist, right, is kind of function is ideal function to conduct hypothesis testing for small sample size, small sam small data size. Okay, okay. So yeah, so let's do some calculation. So we we need okay, so we need three arguments here. Okay, the reason why we put two behind because I use two-sided hypothesis testing. Okay, so hit enter. Okay, so basically, right, the p-value here is pretty small. It's very small. So don't forget we always need to compare the p-value with our significant value. So in this case, I also say that maybe significant value is 0.05. Okay, so okay, you can see since our p-value is smaller than 0.05, basically what we can do is the data provides sufficient evidence to us to reject the null hypothesis, whereby these two variables they are having a positive linear relationship. Okay, okay. So yeah, so basically that's all for the Pearson t-test. Okay, so for more details you can just read through the slides and study yourself. Okay, thanks. That's all for today.